Hello students, how are you? Hope you are doing well. Now the question is, a conducting wire connects two charged conducting spheres such that they attain equilibrium with respect to each other. The distance of the separation between the two spheres is very large as compared to either of their radii. The ratio of the magnitudes of the electric fields at the surfaces of the two spheres is option A R1 upon R2, option B R2 upon R1, option C R2 square upon R1 square, and option D R1 square upon R2 square. So the problem is based on the topic the electric field and electric potential. So we have to remember the relationships. The relationship for the potential is given by K Q upon R, where this particular potential corresponds to the potential at a point due to a charge Q, which is separated by this point to the point P by a distance of R. So if there is a charge placed at a certain point, for example this point is A and here is the charge Q, then the potential at point P is given by this relationship KQ upon R, and the electric field is given by the relationship at this particular point. The electric field is given by the relationship KQ upon R square. So we are going to use these two relationships to solve this particular problem. Now the situation is this: there are two conducting spheres. For example, this is sphere number 1, this is sphere number 1, and this is sphere number 2. And these are separated by a large distance and then connected by a conducting wire. So conducting spheres connected by conducting wire. So when they are connected with each other, then their potential becomes same. After a certain time, the potential of these two conductors became same. Their radii are respectively R1 and R2. This is R1 and this is R2. These are the respective radii. Now according to the given condition that they are connected with a conducting wire, then their potentials are same. So we can say that V1 equals to V2. And V1 is K Q1 upon R1 and V2 is K Q2 upon R2. So this is the particular relationship. From here we get Q1 upon Q2 is equal to R2 upon R1. So this is the value of the ratio Q1 upon Q2. This is R1. This is R1 upon R2. Q1 upon Q2 is R1 upon R2. R1 upon R2. Now the electric field. The electric field, as I have said, that it is given by KQ upon R square. So the electric field corresponding to the first one, the first sphere is K Q1 upon R1 square, and for the second sphere it is E2, which is K Q2 upon R2 square. Now this K cancels with this K and we get this value as Q1 upon Q2 multiplied by R2 square upon R1 square. Now we can put this value, this ratio Q1 upon Q2, which is R1 upon R2, here. So we get this value as R1 upon R2 multiplied by R2 square upon R1 square. So this R2 cancels with this square and this R1 cancels this square, and we get the final ratio as R2 upon R1. So we can see that the ratio of the electric field, respective electric fields of the spheres, is the R2 upon R1, this particular value. So we can see that option D is correct here, R2 upon R1. So this is the solution of this objective question. So hope you understand the solution. Thank you.